In JavaScript, we can actually extract numbers out of strings that have numeric characters in them. Let's see how that works. So far, every time we've created a number, we've used what we've called a literal notation, meaning that in our JavaScript code, our numbers are literally represented as code. However, sometimes we may want to get numbers out of perhaps a string. So if we had a string with the value 197 in it, this doesn't do us much good for, let's say, arithmetic operations. We can't add other numbers to it because it's a string. So how do we get a real number out of a string? Well, one method we could do if we want a whole number is to use a method called parseInt. And this is a built-in function to JavaScript, so the way we use it is type in parse, all lowercase, with a capital I and T, and then we open up parentheses, placing the number inside. Now this is the easiest way to do this, and the int stands for integer. Remember earlier I was talking about the difference between integers and floats. However, remember that numbers don't have this distinction when they're represented in JavaScript. However, there are two different functions, parseInt and parseFloat, which will return you either a whole number or the number with the included floating point precision. This is just a convenience because usually you either want to pull out a whole number or the whole floating point number out of a string. So let's just focus on pulling a whole number or an integer out of a string. So if we take our j of parseInt 197 and we refresh our browser, type in j, and we get 197, the number, not the string. So we could do j plus 2 and we get 199. So this is how we can get a number out of a string. Now what would happen if our number was something like 0, 1, 2? Now we saw what happened when this is a literal, but let's see what happens in parseInt. If we refresh, type in j, we get the actual number 10. Now again, this may seem confusing because we think it would be 12, but remember the leading 0 represents it as an octal form. Now, what would happen if we type in 019? Well, it kind of depends. Let's check it out. We get the number 1. So we get some strange behavior. To solve this problem, if we know that our representation is a decimal representation, we want to add a second argument to parseInt, which is the radix, which is the base of the number system we want to parse. Normally we want to parse the decimal, so our second argument would be 10, meaning that our number is base 10, so 019 should be the number 19. So if we refresh, type in j, now we should see that it's the number 19. Now this is something that you'll learn after making this mistake a lot of times in JavaScript. So here's the lesson. Anytime you use parseInt to get a number out of a string, you really want to add the second argument of 10, unless you're specifically working in a different base. Because you may not know what the actual string representation of a number is, because it may be stored in a variable, or it may come from a user, or another situation, you don't know if it will have the weird properties, for instance, leading with a 0. By adding the second argument of base 10, you're assured that anytime it parses an integer, it will always be done in base 10. And then the format of the actual number in the string won't matter. It won't change the base that is parsed. To make this even more confusing, if we just did parseInt 0, 1, 2, in some implementations it will represent it as an octal, and in some a decimal. So even though you can get away with not putting the second argument to parseInt in, you always want to, because you're being very specific about what type of number you're parsing out of your string. So just always use "10" when parsing an integer out of a string. Now we could use parseInt and the radix operator to do some other interesting things. For instance, if we wanted to parse binary out of it, we could use the base 2 as a binary operator, which means the only digits we could use in our string are 0 and 1. And if you had a binary string of some sort, for instance, 0s and 1s, and let's change this to k. And if we refresh and type in k, we'll see that the 0, 1, 0, 1, 1, 1 representation in base 2 is the number 23. So this radix argument is an arbitrary number, so we could do 3, and that will change what k is. Very rarely do you work in a base 3 number system, but you can change it to 8 for octal and get the correct numbers. But most of the time, you're going to want your radix operator to be 10. So what happens if we do parse int with some non-digits in it? So let's say we do 23 people. And remember, anytime we do parse int, we always want to add a radix here of 10. So if we refresh and take a look at L, we'll see it's 23. It parsed it out pretty well. However, what if we did there are 23 people and we refresh? We get an interesting value called nan. And nan stands for not a number. And this is a value that's used in JavaScript to represent a value that is, well, not a number. Now, nan has some interesting properties. If you, for instance, try to add a number to nan, so we'll take L, which is not a number, and add 14 to it, we get not a number. In fact, if we do any type of operation to not a number, the result is always not a number. So if at any point in time you do an operation like parse int that could return not a number, you want to check for it because any operations that you do after that will result in those results being not a number all the way up. So you may see NaN show up in your JavaScripts when you don't expect it. That means at some point not a number showed up. So how do we check for not a number? So we know L is going to be not a number. So you might think we could do triple equals NaN. Now see, it highlights because not a number is something that we can use as a literal. But what happens if we actually do this and we refresh? We get false. But we know L is NaN, and for some reason, if we compare the two of them, we get false. Now maybe it's because we're using our strict equality operator. But what if we just try 2 equals? Well, we get false again. And that's because not a number has a curious property of not being equal to itself. So we can see that even comparing the JavaScript variable L to itself returns false. Now you may be tempted to use that to detect not a number, but what you want to do is use a function that's built into JavaScript called isNan. The way we do that is typing is, capital N, lowercase a, capital N. And this takes a parameter, and if we pass in L, which is not a number, we'll see it's true. So nan is a very weird value because it doesn't equal itself or any other number, and has a special function for testing if it is itself. Now the last function I want to talk about here is called parseFloat, and it acts very similar to parseInt. And we'll say parseFloat. And we can say 123.456. And now the number m will be 123.456. And this has the same properties. So if we have stuff after the number, like is a strange number, we can see that m still works. However, if we lead with some other stuff, we'll see that, again, parseFloat returns not a number. So for parseInt and for parseFloat to work, it must start with a number, and then anything after the number really won't affect it, so long as your string starts with something that could be parsed as a number. With parseFloat, we don't have to add the second argument of our radix because parseFloat will work in base 10, really no matter what. So if we did this and checked a value of m, we still get 123.456. So parseInt and parseFloat are the two functions you would use to get a number out of a string. So now we've seen the different ways we can create numbers or even parse them out of a string. Up next, we'll look at the mathematical operators we can use on our numbers.